Have a nice day, my dear viewers and my dear students and pupils. I am Cassian Perera. This is my channel, which is called Cassian Perera. I started this channel about 4 years ago to conduct engineering studies at the first time in Sri Lanka in a YouTube channel. Here, I conduct engineering studies, engineering mathematics, fluid mechanics, thermodynamics, solid mechanics, soil mechanics, mechanics of machines. And I conduct this channel as educational channel. Therefore, I conduct 2 special video series which are called The Base of Our Knowledge and The Musical Meditation, by which I am going to shape of our students or pupils human values. Now, first of all, I am going to thank for all viewers who have contributed to my channel by participating as commenting comments or likes or subscribing my channel. I pray for them also, for their good future. Now, today I am going to conduct a video on mathematics. Let's see what the video is. Now, this video is on series. This series 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8 plus etc. Is it convergent or divergent? Let's see, is it convergent or divergent? Now, at first, let's see the difference between the 2 words called sequence and series. Now, sequence is a set of numbers actually arranged in a specific pattern. Normally, students learn sequences from grade 5. For example, say 1, 2, 3, 4, 5, like that. Or 1, 2, 4, 8, 16, etc. Or 1 upon, 1/3, 1/6, 1/12, 1/24, etc. Now, those are actually called sequences. Why? We write numbers in a specific order. Actually, we have represented these numbers and separating these adjacent two numbers by commas. These numbers are called terms of the sequence. Now, series is actually sum of some set of numbers. These numbers are in a sequence. Actually, if you wrote the above sequence 1, 2, 3, 4, 5 as a sum 1 plus 2 plus 3 plus 4 plus 5 plus like that, it's a series. Now we can find the sum of this series. If you got 1 plus 2 plus 4 plus 8 plus 16 plus something, it's also series. Now, let's see the next one. 1 plus 1/3 plus 1/6 plus 1/12 plus 1/24 plus 1. Like that. Sometimes we can get the summation up to infinity terms. Now, let's see what happens in our series. 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus 1.5 plus 1.6 plus 1 upon 7 plus 1 upon 8 plus like that. We can see these numbers or terms of the series are in decreasing order. When you are going from left to right, these numbers are in decreasing order, but sum is, if you got one half, first one is half, the sum of two terms, 1 over 2 plus 1 over 1 upon 3. If you got three terms, 1 upon 2 plus 1 upon 3 plus 1 upon 4. Four terms, 1 upon 2 plus 1 upon 3 plus 1 upon 5, 4 plus 1 upon 5. Likewise, we can write the partial sum of this series. If you got partial sums are increasing from left to right, but increasing amount is decreasing. Because if you got say 1 upon 5 is less than 1.4. Therefore, if we go from left to right, the increasing amount of the sum is decreasing. But we can write this sum is in notation like this: sigma from n equals 2 to infinity of 1 upon n. Here, when n equals 2, we say 1 upon 2. When n equals 3, 1 upon 3. When n equals 4, 1 upon 4. When n equals 5, 1 upon 5. Now, this sigma sign represents the sum of these all numbers. Here, n is a natural number and n is greater than or equal to 2. Now, let's see here. This is our series. N from 2 to infinity, that is 1 upon n, is equal to 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus 1 upon 5 plus 1 upon 6 plus 1 upon 7 plus 1 upon 8 plus 1 upon 9 plus 1 upon 10 plus 1 upon 11 plus 1 upon 12 plus 1 upon 13 plus 1 upon 14 plus 1 upon 15 plus 1 upon 16 plus. Likewise, we can go up to infinity. Now, I am going to explain in a different way. Say, 1 upon 3 is always greater than 1 upon 4. If you added 1 upon 4 for the both sides of this inequality, it becomes 1 upon 3 plus 1 upon 4 is greater than 1 upon 4 plus 1 upon 4. It implies 1 upon 3 plus 1 upon 4 is greater than 2 upon 4. That implies 1 upon 3 plus 1 upon 4, it is greater than 2 upon 4 means 1 upon 2 half. It is implied by this equation 1. Now say, as the 1 upon 5 is greater than 1 upon 6, greater than 1 upon 7, is greater than 1 upon 8. Now, in the same procedure we have used earlier, we can apply here also. 1 upon 5 plus 1 upon 6 plus 1 upon 7 plus 1 upon 8 is greater than 1 upon 8 plus 1 upon 8 plus 1 upon 8 plus 1 upon 8. Because 1 upon 8 is the smallest number among 1 upon 5, 1 upon 6, 1 upon 7, 1 upon 8. Therefore, 1 upon 5 is greater than 1 upon 8. 1 upon 6 is greater than 1 upon 8. 1 upon 7 is greater than 1 upon 8. Therefore, 1 upon 8, 5 plus 1 upon 6 plus 1 upon 7 plus 1 upon 8 is greater than 4 1 upon 8s. 4 1 upon 8 means 4 upon 8. It implies half. Again, half. Therefore, it implies 1 upon 5 plus 1 upon 6 plus 1 upon 7 plus 1 upon 8 is greater than 1 upon 2. It is stated in equation 2. The same way we can write 1 upon 9 is greater than 1 upon 10, is greater than 1 upon 11, is greater than 1 upon 12, is greater than 1 upon 13, is greater than 1 upon 14, is greater than 1 upon 15, is greater than 1 upon 16. That implies every and each member here say 1.9 or 1.10 or 1.11 or 1.12 or 1.13 or 1.14 or 1.15 is always greater than 1.16. Therefore, if you got the summation from 1.9 to 1.15 is greater than 1.16 plus 1.16 plus 1.16 plus, likewise 8 of 1.16. 8 of 1.16 means 8 upon 16. Therefore, it is half. Therefore, it implies 1.9 plus 1.10 plus 1.11 plus 1.12 plus 1.13 plus 1.14 plus 1.15 plus 1.16 is greater than half again, as given in equation 3. Therefore, we can write this sum like this. Our series is 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8 plus 1/9 plus 1/10 plus 1/11 plus 1/12 plus 1/13 plus 1/14 plus 1/15 plus 1/16 plus and so on. But 1/2 is equal to 1/2. At the first I wrote 1/2. Instead of 1/3 and 1/4, I wrote 1/2 again. Instead of 1/5, 1/6, 1/7, 1/8, I wrote again plus 1/2. Instead of from numbers 1/9 to 1/16, I wrote again half. This sum is half, 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 half. Sum is always less than the sum of the series mentioned above here. 1/2 plus 1/3 plus 1/4 plus 1/5 plus up to 1/16 plus and so on is always greater than 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1 plus and so on series of halves. Then we can say, therefore, sigma n equals 2 to infinity of 1/n is always greater than the series in halves. The series in halves is also infinite series. Say it is going from m equals 1 up to infinity. M is the actually, if you wrote here, M is there is a relationship between n and m. N mentioned in our series and m mentioned here. N is equal to 2 to the power m. Now say when m equals 1, n equals 2 to the power 1 means 2. N equals 1. When n equals 2, here, if you wrote m equals 2, 2 to the power 2, therefore we have n equals 4. The initial series ends up to 1/4. When n equals 3, n equals 2 to the power 3, that is 8. The initial series ends up to 8, 1/8. Likewise, the relation between n and m, n equals 2 to the power m. Therefore, the logarithm of n related to 2 is m. Therefore, we can write here sigma n equals 2 to infinity of 1/n, n is greater than sigma m equals 1 up to infinity of m divided by 2. Because m divided by 2 means we have m terms of half. Half into m, that is m divided by 2. But m is going from 1 to infinity. Then we can write sigma from n equals 2 to up to infinity of 1/n is greater than here m equals 1 means n equals 2. N equals 2 to infinity of log 2n divided by 2. But we can write log 2n divided by 2 when n equals 2 to r. I get the general term r when n equals r, but r tends to infinity. Limit of this sum when r tends to infinity. It is the same as when n equals 2 to infinity of log 2n upon 2. Now, if you got this limit or sum of log 2n upon 2 when n equals 2 up to infinity, when n tends to infinity, logarithm of also tends to infinity. Therefore, the sum is always tends to infinity. We can't find finite value. Infinity, it's infinite value. Therefore, we say limit does not exist. Limit does not exist means it is this M series also divergent. But we proved here the sum of our series when n equals 2 up to infinity of 1 upon n is always greater than the sum of M series. But M series sum is infinity, therefore it is greater than infinity means it's also another infinity which is greater than this one. Therefore, we can say our series is divergent. That is sigma n equals 2 up to infinity of 1 upon n is divergent. But we can't believe it. According to mathematics, it says 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus likewise. We can see it, the succeeding term is always less than the preceding term. Even though it happens, it is diverging. That is our result. Thank you.